Here are two numbers that should never be allowed on the same page. The universe is 13.8 billion years old, and the most distant regions we can see are sitting, tonight, about 47 billion light-years away. Read them again, slowly this time. Nothing in this universe travels faster than light. Nothing ever has. That rule has been tested for over a century, and it is never lost. So if the universe has only existed for 13.8 billion years, then nothing inside it should be more than 13.8 billion light-years from anything else. There simply has not been enough time, and yet 47 billion is the number. It sits in the textbooks. It has been measured, checked, argued over, and confirmed. One of those two numbers looks like a typo. Neither one is. Most stories like this would make you wait 90 minutes for the answer. I am going to hand it to you in the next few minutes. Because the answer is real. The answer is measurable. And the answer is stranger than the mystery. But I need you to hear something first. And I need you to hold on to it all night. The number was never the scary part. The scary part is what that number refuses to be. It refused to be a destination. There is no ship you could build, no engine you could invent, no beam of light you could fire tonight that will ever arrive there. And before this night is over, I am going to prove that to you using nothing faster than a flashlight. So let us deal with the typo that is not a typo. The 47 billion light-years is the distance to the edge of what astronomers call the observable universe. Keep the word observable close, because it is carrying more weight than it looks. It marks the border of everything we can see, everything we can measure, everything that has ever managed to send so much as a single particle of light to this planet. Inside that border sit roughly 2 trillion galaxies. Every star ever photographed, every world ever imagined, every piece of the sky that has ever had a name, all of it lives inside that line. And the reason two impossible numbers can both be true is simple to say and very hard to feel. The space between us and those distant regions has not been sitting still, while their light crawled toward us across billions of years. The road it was crawling along kept stretching. The light traveled for 13.8 billion years. The starting line, meanwhile, was carried backward, farther and farther, until tonight it sits 47 billion light-years behind the finish. Nothing broke the speed limit. The racetrack itself grew. That is the honest answer. And you now own it. 12 minutes ahead of schedule. But notice what the answer just did. It quietly traded your question for a bigger one. Because if the road to the edge is stretching while you travel it, then the distance to the edge is no longer a number you can write down and trust. It is a number with a motor attached. Tonight it reads 47 billion. Tomorrow night it will read something more. Which forces the question this whole night actually turns on. And it is a question almost nobody thinks to ask. The distance to the edge of what? Exactly. Because everything I have said so far assumes there is something out there to measure to. A line. A boundary. A place where the universe runs out. Every map you have ever seen of the cosmos draws it that way. A great glowing sphere of galaxies with us at the middle, and a crisp edge all the way around. Like a snow globe. And the first genuinely unsettling thing you learn on this road is what happens to that picture the moment you take it seriously. You fly out there. 47 billion light-years. Farther than any number a human mind can hold. You arrive at the exact spot the maps call the edge of everything. And there is nothing standing there at all. Every one of us carries the same picture in our heads. And it is worth saying out loud so we can look at it honestly. The universe is a very big place. The picture says, but a big place is still a place, and places end. Somewhere out past the last galaxy there should be a final boundary, a wall, a skin, something a spacecraft could someday fly up to, cut its engines, and float in front of, with all of creation on one side of the window and something unthinkable on the other. That picture feels so natural that it seems rude to question it. It is also wrong, and the fastest way to see why is to leave space entirely and go stand on a boat. Put yourself in the middle of the Pacific Ocean, alone, on a clear day. Look around you. The world you can see is a perfect circle of water, and you are standing at the exact center of it. The circle has a sharp, clean border. Sailors have been staring at it for as long as there have been sailors. We even gave it a name, the horizon. It sits about 3 miles out in every direction. It is absolutely real, and you can measure the distance to it with nothing but your own height and a little geometry. Now sail toward it. You can sail for an hour or a year. You will never reach it. And here is the part that matters. You will never reach it because there is nothing there to reach. There is no line painted on the ocean 3 miles out. No seam in the water. The horizon was never a feature of the sea. It was a feature of you. It marks the limit of how far light can travel to your eyes around the curve of the earth from where you happen to be standing. Move. And it moves with you. Every ship on every ocean sits at the center of its own private circle. And no two circles are the same. And not one of them exists as an object in the world. Keep that boat in your mind, because the edge of the observable universe is the same kind of thing, scaled up until it stops being harmless. The border 47 billion light-years out is a horizon. It marks the limit of how far away something can be and still have had enough time, in the entire history of the universe, to get a message to us. Light from inside that border has reached Earth. So, we see galaxies there, and we take their pictures, and we give them names. Light from beyond that border has not reached Earth. That is the whole difference. On one side of the line, the mail has arrived. On the other side, it has not. And here is what that means for the snow globe picture. If you could somehow stand at the spot we call the edge, you would find yourself floating in perfectly ordinary space. Galaxies ahead of you, galaxies behind you, stars being born, planets turning, the same cosmic scenery running on in every direction, completely unbothered by the fact that some distant creatures on a small blue world have drawn a line through this neighborhood on their maps. Nothing out there ends. What ends is our information. The universe almost certainly keeps going past that line. How far? Nobody on Earth can tell you. And any voice that claims to know is selling something. What we can say is that our maps stop there. The way a lighthouse beam stops in the fog. The beam does not mark the end of the sea. It marks the end of the light. Now, if the edge is a horizon, you might feel the whole mystery deflating. Horizons are harmless. The one on the ocean never hurt anybody. It retreats politely as you approach. And given a fast enough boat, you can chase it around the entire planet and come home for dinner. So surely this one works the same way. Surely the cosmic horizon is just a bookkeeping line. And a patient enough traveler with a fast enough ship could push through it. Mile by mile. Forever. Revealing new galaxies the way a sailor reveals new water. That is exactly what a reasonable person would think. It is what astronomers themselves assumed for most of a century, and it is the assumption this entire night is about to take apart, piece by piece, because the horizon around this planet does something the one on the ocean never does. The ocean horizon waits for you. It sits at its fixed few miles and lets you close the gap. The horizon in the sky is not waiting. The space between here and there is stretching. Right now. Tonight. While you watch. And the stretching is faster, the farther out you look. Somewhere along that road, the ground itself is being added faster than any traveler can cross it. Chasing this horizon is sailing toward a line that is being carried away from you by the ocean itself, which means describing the edge any further is a waste of a good night. There is exactly one honest way to find out what this boundary really is, what it does to anything that dares it, and why the word terrifying belongs in the title over your screen. We stop describing it. We race it. And we are not going to race it with a ship. Ships are slow. Ships break. And every ship humanity has ever launched would lose this race before it cleared the driveway. We are going to enter the fastest thing that has ever existed. The one contestant in this universe that has never been beaten by anything. And we are going to fire it at the edge of everything tonight. Straight up. From this planet. While you watch. The starting gun goes off in Chapter 3. Every race needs a contestant. So let us be honest about ours before we put it on the track. Because the first instinct, the human instinct, is to send a machine, a probe with our flag on it, something built in a clean room in California with gold foil and a camera, something we can love. And if this channel has taught its viewers anything across its long nights, it is what happens to machines on roads like this one. Their fuel runs out, their parts wear down, their speed. Even at the wildest edge of anything on any drawing board, is a crawl dressed up in a press release. Send the finest spacecraft humanity will ever build toward the edge of the observable universe, and you have not entered a race. You have thrown a paper boat into the Pacific. So tonight we are going to skip the entire argument, every debate about engines, every fantasy about fuel, every clever design that always dies in the same arithmetic. We are leaving all of it on the launch pad. Tonight we send the one thing in this universe that ends the conversation about speed. We send light itself, a single pulse of it, a photon, aimed straight out from this planet at the deepest patch of sky we have ever photographed. And I want you to appreciate what kind of contestant you are about to watch, because there has never been another one like it. A photon moves at 670 million miles per hour from the instant it exists. It does not accelerate to that speed. It is born at that speed, full stride from the first moment. Like a sprinter who begins mid-leap, it never slows down. It never rests. And it never ages. This is measured physics. Strange as it sounds. At the speed of light. No clock runs at all. A photon cannot wear out and cannot break down, because there is nothing in it to break. It needs no food, no fuel, no repair, no crew, no hope. Every enemy that has ever killed an interstellar dream, the tanks and the bearings and the aging hearts, none of them can even find this thing to attack it. The speed of light is not the fastest speed we know of. It is the fastest speed there is. It is stitched into the fabric of physics as the hard ceiling of the universe. Tested for over a century in every laboratory on Earth. And it has never once been beaten by anything. Not by particles. Not by signals. Not by information itself. Which is exactly why tonight's race matters so much. Because we are not asking whether some gadget is good enough anymore. We are putting the universe's own speed limit on the track. The best answer that will ever exist. The contestant that cannot be improved by any technology from any civilization in any century to come. If this racer cannot reach the edge, then the problem was never engineering. Then no one from here or from anywhere, will ever solve it with a better machine. Because there is no better machine than the one we are firing tonight. If light loses this race, the road itself is the killer. So here is the moment. Picture a mountaintop observatory. Late tonight, the dome open to a clear black sky. Somewhere overhead sits a patch of darkness no wider than a grain of sand held at arm's length. And inside that tiny patch, our deepest telescopes have counted thousands of galaxies. That is the target. That is the direction of the deepest thing we have ever seen. A laser fires. One pulse. The photon clears the top of the atmosphere in a couple hundred thousandths of a second. By the time you finish this sentence, it has passed the moon. Before this chapter ends, it will cross the orbit of Mars. It is gone, out of the solar system's front yard, running at the full speed limit of reality. And it will hold that speed without a single wasted moment for as long as this universe exists. We are going to check on our messenger all through the night. It is the thread this whole story hangs on. But before we follow it out into the dark, I want you to mark this exact moment and keep it somewhere safe. Because this moment, the flash on the mountaintop, the pulse clearing the atmosphere, is the last moment of the entire night, when this trip still looks winnable, 4 years and 4 months after launch. Our Photon passes the first landmark, and it is worth slowing down for, because it is the last landmark a human being might ever visit. Alpha Centauri, the nearest star system to our Sun. On the scale of tonight's journey, it is the mailbox at the end of our driveway. And it took the fastest thing in existence more than 4 years of flat-out running to reach it. Set that against our machines for 1 second, just to bury them properly. The farthest outbound spacecraft humanity has ever launched, still transmitting faithfully from beyond the planets. We would need somewhere north of 70,000 years to cover the distance our Photon just covered in 70,000 years. That single comparison is the entire reason there is no spaceship in this story. Our racer crossed it between 2 chapters, and it has not even started. So let it run. A century of flight. 2 centuries. The Photon threads outward through the quiet suburbs of the galaxy, past star after star, each one a slow porch light drifting by over decades. After about 1,000 years, it has passed most of the stars you can see with your naked eye on a dark night. Everything you have ever personally looked up at, every star in every constellation you can name, sits inside the first 1,000 light years. The Photon clears it all while, back home, Rome rises and falls. Now give it 100,000 years. That is what it costs, at the absolute speed limit of the universe, to cross our Milky Way galaxy from edge to edge. 100,000 years. Wall to wall, through a few 100 billion stars. And here is the ruler for it. When our Photon entered the galaxy's far side, back on Earth, the entire recorded story of our species had not happened yet. Every city, every farm, every written word, every war, every song, all of it fits inside the time our messenger needs to cross 1 galaxy, and the observable universe contains around 2 trillion of them. The Photon does not pause at the exit. It launches off the rim of the Milky Way into true intergalactic space. And for the first time all night, the scenery goes silent. 2.5 million years of nothing. That is the gap to Andromeda, our nearest large neighbor, the most distant object your naked eye can find on a dark autumn night. 2.5 million years of flight to reach the thing you can see for free from your backyard. When the Photon finally sweeps past Andromeda's spiral arms, The trip meter reads 2.5 million light-years. And I have to tell you what that is as a fraction of tonight's journey. Because this is where the scale of this story bears its teeth. 2.5 million light-years is roughly 0.005% of the distance to the edge. Say it another way. If the entire trip were a road running the width of the United States, coast to coast, our Photon has now traveled about 700 feet. Keep going. There is nothing else to do. 10 million years. 100 million. The Photon leaves our little cluster of galaxies behind. And out here, the universe finally shows its true architecture. The structure no backyard telescope ever reveals. Galaxies, it turns out, are not scattered through space like salt spilled on a table. They are strung together. Gravity has spent 13 billion years pulling them into immense glowing threads. Filaments of galaxies, hundreds of millions of light-years long, woven around gigantic dark hollows where almost nothing lives at all. Astronomers call the hollows voids, and some of them are 300 million light-years across. Empty rooms so large that light needs 1/3 of a billion years to walk from one wall to the other. Seen from far enough away, the whole observable universe looks like a sponge, or soap foam frozen mid-bubble. Thread and hollow. Thread and hollow. Repeating in every direction as far as any telescope has ever reached. Our Photon now flies through that foam, crossing a glowing thread over millions of years, then falling into a void for an age of silence, then rising into the next thread, and at last, after 1 billion years of perfect, tireless, flawless running, let us call our messenger and ask for a status report. The news sounds good. 1 billion light-years down. The Photon has crossed 1 million galaxies worth of scenery. Back on Earth. 1 billion years is deep time, beyond deep time. When the Photon launched, if we run the film backward that far, there were no animals here. No plants. No insects. Nothing with a shell or a spine. Life was single cells in the sea, and it would stay that way for hundreds of millions of years more. Our racer has been flying for the entire span from that world to this one. And the trip meter reads 1 down. 46 to go. Do that division, and you get the first honest forecast of the night. At this pace, the Photon arrives in roughly another 46 billion years. 46 billion. The number is a monster. More than 3 times the current age of the universe. Long enough for the sun to die, and for most of the bright stars in tonight's sky to burn out and go dark before the finish line. But notice something about that monster. Something almost comforting. It is finite. It is a number. Write it down. Circle it. And the trip becomes merely absurd instead of impossible. A finish line exists. The racer never tires. And given enough patience, arithmetic says our Photon crosses it. Absurd. But winnable. That is the forecast. Except that forecast is built on a lie. And the lie is not in the Photon. And it is not in the distance. The lie is hiding inside the one thing I never mentioned. Every mile of this chapter, every landmark, every division I just did for you, all of it quietly assumed that the road holds still while the racer runs it. In the autumn of 1929, on a mountaintop above Los Angeles, 2 men found out that it does not. One of them was a lawyer who walked away from the law. The other drove mules up that mountain for a paycheck and never finished high school. Between them, they caught the entire sky in the act of running away. An hour's drive northeast of Los Angeles. A narrow road climbs almost 6,000 feet up the San Gabriel Mountains to a peak called Mount Wilson. In the early 1900s, before that road existed. Everything needed to build an observatory on that summit went up a mule trail. The lumber, the steel, the pieces of the largest telescope mirror on Earth. All of it hauled around switchbacks on the backs of animals, and leading those animals up the mountain. For $1 a day was a teenager named Milton Humason. Remember his name, because nobody at the time thought they needed to. Humason had dropped out of school at 14. He had no degree, no training, no credentials of any kind. What he had was a love for that mountain. And when the mule work dried up, he took the only job the new observatory would give him: janitor. He swept the floors of the most advanced astronomical facility on the planet. And at night, when the astronomers needed an extra pair of hands, he volunteered. He learned to guide the great telescopes by standing at them. Hour after freezing hour, he learned to develop the fragile glass photographic plates without cracking them. And slowly the staff noticed something almost unfair. The janitor had the steadiest hands and the most patient eye on the mountain. By the 1920s, the man who never finished high school was operating the 100-inch Hooker telescope, the most powerful instrument on Earth, as its finest observer. Sharing that summit with him was a man built from entirely different material. Edwin Hubble had been a college athlete, a Rhodes Scholar at Oxford, a trained lawyer who practiced for less than a year before admitting he could not stand it, and a major in the army during the First World War. He arrived on Mount Wilson wearing English riding clothes and smoking a pipe, speaking in a British accent he had brought home from Oxford on purpose. Colleagues found him arrogant, distant, impossible to be friends with. They also found him to be on the big questions, almost supernaturally, right? In 1923, Hubble had already used the 100-inch to settle the greatest astronomical argument of the age, proving that the fuzzy spiral clouds in the night sky were not clouds at all but entire separate galaxies, islands of hundreds of billions of stars, unthinkably far beyond our own. With one photographic plate, he had made the known universe thousands of times larger. That discovery alone would have carved his name into history. It was the warm-up act, because scattered through the world's observatories was a strange, unexplained clue, and Hubble could not leave it alone. Years earlier, an astronomer named Vesto Slipher, working at a small observatory in Arizona, had done something painstaking. He had split the light of those spiral galaxies into rainbows, into spectra, and measured them. Light carries a fingerprint. Every chemical element stamps dark lines into a spectrum at exact known positions. And those lines behave like a pitch. If the source of light rushes toward you, the lines shift toward the blue end of the rainbow. If it rushes away, they slide toward the red. Astronomers call it redshift, and it works on the same principle as the siren of a passing ambulance. Pitched high as it approaches, dropping low as it recedes. Slipher had spent years measuring a few dozen galaxies, and his velocities were the early evidence everyone else would build on. Almost every single one was shifted red. Almost everything out there was moving away from us. Nobody knew what to make of it. A curiosity, maybe, a neighborhood quirk. To turn a clue into a law, you needed two numbers for each galaxy: its speed and its distance. And distance was the killer, the hardest measurement in all of astronomy. Speed alone told you nothing. So the mountain went to work, and the partnership itself is half the story. The Rhodes Scholar and the mule driver, Hubble hunted the distances, searching each galaxy for a special class of pulsing stars whose flashes revealed how far away they burned. Humason took on the speeds, and his part of the job was brutal: To catch the spectrum of a faint galaxy, he had to hold the giant telescope locked onto a smudge of light through exposures that ran 5 hours, 10 hours, sometimes stretched across multiple freezing nights on the same small glass plate, guiding by hand and by eye the entire time, in an unheated dome, in the dark, without one slip, one shake and the plate was garbage. Humason did not shake. By the winter of 1929, Hubble laid the 2 columns of numbers side by side, Slipher's velocities and his own hard-won distances, and drew the picture. The picture was a straight line. Every galaxy was running away from us, and the speed of its escape was locked to its distance by the simplest law imaginable. Twice as far meant twice as fast. 10 times as far. 10 times as fast. A galaxy's distance told you its speed. Cleanly. Predictably. Like a train schedule for the entire sky. Near galaxies drifted away at a few hundred miles per second. The far ones fled at thousands. And after 1929, it was Humason who carried the law outward, plate by plate, pushing the measurements to galaxies many times deeper than anything in the original paper, catching systems receding at over 25 million miles per hour. And still, the straight line held. Now, a straight line like that will play a trick on your intuition. And we need to kill the trick right here, because the rest of tonight depends on it. The trick whispers that if everything is running away from us, then we must be standing at the center of some great explosion, at the exact spot the universe is fleeing from. It looks that way. It is not that way. And the proof is hiding in the pattern itself. Bake a loaf of raisin bread. Before it goes in the oven, the raisins sit scattered through the dough, 1 inch apart, 2 inches, 3. Now let the dough rise until the loaf doubles in size. Stand on any raisin you like and look around. The raisin that was 1 inch away is now 2 inches away. So it moved 1 inch during the bake. The raisin that was 3 inches away is now 6. So it moved 3 inches in the same amount of time. 3 times the distance. 3 times the speed. From your raisin, every other raisin is receding, and the far ones are receding fastest, in exact proportion to their distance. Which raisin is the center of that? Every one of them. No one of them. Pick any raisin in the loaf, and the view is identical. Nothing is moving through the dough at all. The dough itself is growing, and it carries every raisin away from every other raisin. Everywhere. All at once. That is what Hubble's straight line was actually saying. And it is the single deepest sentence this night will ask you to absorb. The galaxies are not flying away from us through space, fleeing some ancient blast with us at the middle. The space between the galaxies is stretching. The universe is the loaf, still rising. Every galaxy sits in its own patch of calm, held together by its own gravity, while the gaps between the patches grow wider by the hour. Stand anywhere in this universe, any galaxy, any star, any world, and you will see exactly what those photographic plates saw from Mount Wilson. Everything. Receding. The far things. Receding fastest. The sky is not running away from you. The sky is running away from itself. A century of measurement has hammered on that conclusion from every direction, with satellites and space telescopes and instruments Hubble could not have dreamed of. And the conclusion has held. The expansion is real. It is one of the most thoroughly confirmed facts in all of science. And in 1929, it detonated under human knowledge with one instant, universe-sized consequence. If the loaf is rising today, then yesterday it was smaller. Run the film backward far enough, and everything now scattered across billions of light years was once pressed together, hot and close, at a single beginning. The expanding universe is the reason we know there was a Big Bang at all. The mule driver's frozen nights at the eyepiece are at the bottom of the chain of evidence. Why the number 13.8 billion exists. Milton Humason was eventually given an honorary doctorate for helping discover the scale and motion of the universe. Not bad for the janitor. But tonight we are not here for the history. And you may have already felt the floor shift under this chapter. Go back to our photon. It is out there right now. 1 billion light years deep, running at the perfect speed limit of reality toward a finish line, 46 billion light years ahead. And our comfortable forecast. The 46 billion year arrival, the absurd but winnable race, was computed on a frozen map. Measure the road. Divide by the speed. Mark the calendar. Hubble and Humason just burned the map. The road to the edge is made of space. And space is the dough. And the dough is still rising. Every mile, our messenger crosses tonight. The miles remaining are quietly multiplying ahead of it. And the farther it flies, the faster the road it stands on grows. Our racer has not slowed down by a single step. It never will. And it is in far more trouble than any number in this chapter can yet express. To see how much trouble, we have to ask a question that sounds absurd. How can a runner who never slows down still lose ground? Every big airport in America has one. So you have almost certainly ridden the machine we need for this chapter. The moving walkway, the flat conveyor belt for people, sliding along between gates, with the recorded voice telling you to hold the handrail. Step on, and the belt adds its speed to yours. Every traveler loves that direction. Tonight, we need the other direction. Turn around and walk against it. Walk against a moving walkway and something interesting happens to the idea of speed. Your legs work exactly as they always have. Same stride. Same pace. Same effort. Anyone standing on the belt beside you watches you walk past them at your normal walking speed. Completely unremarkable. And yet the terminal around you disagrees. Measured against the gates and the windows. You are creeping. Your legs say 3 miles an hour. The building says 1. Nothing about you changed. The ground you are walking on is simply sliding backward underneath your stride. Stealing distance while you make it. Now build the walkway this night actually runs on. Make the belt millions of light years long. Make it stretch instead of slide. Growing everywhere along its length at once, the way the raisin dough grew, so that every mile of it is quietly becoming more than a mile. And put our photon on it. Walking against the growth. Here is the rule that governs everything from this sentence to the end of the night. The photon never slows down. Ever. Measure our messenger locally, in its own neighborhood. Against the space, it is actually passing through, and it moves at exactly the speed of light. Tonight and every night, the full legal limit of the universe. Forever. No exceptions, no fine print, no fatigue. Physics up close is never violated. Not once. Not anywhere in this story. And yet the distance between our photon and its destination can still grow. Because the road is rising like the dough. The photon crosses one stretch of space at the perfect speed limit. And while it does, every stretch still ahead of it lengthens. It is the walker on the belt. Legs flawless. Ground treacherous. Measured against its own patch of space. Our racer is the fastest thing that has ever existed. Measured against the finish line. It can be losing. How badly can it lose? That depends on one thing only. And Hubble's straight line already told you what. Distance. The stretching of space compounds with every mile of road. The same way the far raisins fled faster than the near ones. Between here and a nearby galaxy, the road grows gently, a modest drift our photon crosses without noticing. Between here and a galaxy 10 times farther, the growth is 10 times faster. Keep multiplying the distance and the arithmetic climbs without any ceiling, because there is no speed limit on the loaf. And that sentence deserves to be said carefully, because it sounds like it breaks the one law we have leaned on all night. It does not. And the walkway shows you why. The speed limit of the universe is a traffic law. And traffic laws apply to things moving through space. No object, no signal, no particle may pass through its own local neighborhood faster than light. And nothing ever has. But the stretching of space is not travel. Nothing is passing anything. No galaxy out there feels motion. No stars streak through their sky. Nothing overtakes a light beam in its own neighborhood. The belt is simply growing, everywhere at once. And growth has no speed limit. Add up enough gently rising road between you and something far away, and the total distance between you can increase faster than light could cross it, while every single object involved sits perfectly still in its own patch of space, breaking no law at all. That is not a loophole I am asking you to take on faith. It is measured, standard cosmology, as solid as the expansion itself, and it means the universe contains a number that should raise the hair on your arms, out at the extreme distances, near the regions whose light we already collect in our deepest photographs. The total stretching of the road between us and them adds up to more than 3 times the speed of light. The most distant places we have ever photographed are, tonight, being carried away from us faster than any light beam could chase them. We have their pictures on our hard drives, and the total separation between us is growing by more than 3 light years every single year. Sit with that for a moment, because the race you signed up for in Chapter 3 just changed its nature. Our photon is not crossing a long road anymore. It is climbing a down escalator that runs faster the higher it climbs. And that picture, the escalator that speeds up with altitude, hands us the geometry of everything to come. Close to Earth, the stretching is slow and our photon gains ground easily. Mile after honest mile. Farther out, the road grows quicker underfoot, and the gaining gets harder, which means that somewhere out there, at some exact distance from this planet, there has to be a crossover. A distance where the road between here and there grows at precisely the rate that light itself can fly, where the down escalator matches the climber, step for step for step. Closer than that line, light gains on us or away from us with ease. Beyond that line, pure stretching space outruns the fastest thing in existence. That line is real. It has a location. Astronomers can tell you where it sits tonight, and when they first calculated it. The answer landed so close to a number you already know that it looks like the universe is playing a joke. The line sits about 14.5 billion light years out. A circle drawn around us at 14.5 billion light years. The distance where space itself breaks even with light. And everything about that circle, the way it sits almost exactly where the universe's age says an edge should sit. The way generations of smart people have mistaken it for exactly that. All of it is a trap. The most convincing false edge in the cosmos. Next chapter, we walk up to it and watch it fail. 14.5 billion light years from Earth. There is a line in the sky. You cannot see it, and you could not feel it if you flew through it. But it is as real as the equator, and you can compute its position from a mountaintop with the right measurements. It is the break-even line of the universe. the distance at which the stretching of the road adds up to exactly the speed of light. Inside that line, space between us and any object grows slower than light can fly. Beyond that line, the road grows faster than light itself can run. Astronomers call the sphere drawn at that distance the Hubble sphere, named for the man with the pipe and the borrowed accent. And I want to be straight with you about what it looks like on paper. It looks exactly like the edge of the universe. Think it through the way generations of very smart people have thought it through. Nothing outruns light. Beyond 14.5 billion light years. Space carries things away from us faster than light. So light launched from out there, flying toward us as hard as physics allows, should be like a swimmer stroking upstream against a river that runs faster than any swimmer. The swimmer never arrives. The male never comes. Whatever lives beyond that line should be cut off from us forever. Invisible. Unknowable. Go on. Draw the sphere. Label it the boundary of the visible universe. And close the book. The logic feels airtight. For decades, plenty of textbooks and popular accounts sold it exactly that way. And if you go looking tonight, you will still find famous videos telling this story with total confidence. And the story is wrong. This is the point in the night where most tellings quietly run off the road. So let us take the turns slowly and get it right. We see past the line, tonight, in real photographs, sitting in real archives. We have the light of galaxies that were beyond the break-even line when that light left them. Galaxies whose road to us was growing faster than light could shrink it. The swimmer in the impossible river made it to shore, and our telescopes are full of its pictures. Most of the deep universe we have ever photographed, in fact, comes from beyond that line. The false edge does not leak a little. It leaks from one end to the other. Here is how the trick works. And the beautiful part is that you already own every piece of it. The break-even line is not a wall standing at a fixed address. It is a moving threshold, and it has been moving for the entire history of the universe, because the current at any given distance changes as the universe ages. Go back to the swimmer, stroking toward us. Upstream, in the fast part of the river, locally the swimmer does everything right. Full speed, perfect form, and still loses. The riverbank slides the wrong way past them. Year after year, the gap to us widens. By every instinct you have, that swimmer is finished. But if the fast water calms over cosmic time, the break-even line sweeps outward, and a swimmer losing ground can find the line overtaking them, gathering them into the slow water, where a swimmer at full stroke gains. The river that was carrying them away delivers them into the one region where they can win, and from there they swim home. That is not a fable. It is precisely the biography of the ancient light in our deepest photographs. Those photons launched toward us from beyond the break-even line, lost ground for millions upon millions of years, were carried backward while flying forward, and then the line swept out, gathered them in, and they crossed the slow water for billions of years more until they landed in a camera on a mountaintop or a telescope hanging in space. Every deep field image you have ever admired is an album of impossible swimmers, rescued, every one of them, by a finish line that moved. So mark the scoreboard honestly. The sphere at 14.5 billion light-years is real, and it is not the edge of anything. It is a current in the water, a moving line that light crosses in both directions, and it fails as a wall in the kindest possible way. It lets the mail through. Now turn around, because our own messenger is out there flying the opposite direction, and the same river reads very differently when you are outbound. Run our Photon's future forward, deep into the ages ahead. It flies at the full speed limit. Always. Locally flawless. And the stretching road carries it outward on top of its own speed. So its distance from this mountaintop grows quickly, then very quickly, and somewhere billions of years into that flight, far beyond any calendar a human institution has ever kept. The bookkeeping between our messenger and home crosses a quiet threshold. The total stretching between the Photon and this planet begins adding up to more than the speed of light. From that stretch of its journey onward, the gap between our racer and the place that fired it grows faster than light itself can fly. I want you to watch that moment closely, because it is the moment the trip stops being a trip and becomes an exile. Nothing happens. There is no jolt, no flash, no line painted across space. The Photon does not shudder or slow. Space where it flies is as empty and ordinary as space anywhere else. But from that moment on, our messenger can never be caught, never be recalled, never be updated. Any signal we fire after it is made of light, crawling at the exact same speed, behind by a gap that only widens. Whatever happens to our Photon from here forward, it happens alone, but not yet defeated. And this is where honesty matters more than drama. Crossing the break-even line, by itself, does not settle the race. You just watched ancient Photons cross this same kind of line inbound and win anyway, because the line moved. The question that actually decides our messenger's fate, and the fate of every journey in this universe, is not where the line sits tonight. It is what the river does across the ages. Everything hangs on that. If the current calms with time, the way a river spreads out and slows in a widening valley, then the break-even line sweeps outward forever. The rescues multiply, and given enough patience, almost any swimmer can come home, and almost any destination can be caught. In that universe, our Photon's race is long but alive. If the current strengthens with time, the fast water spreads instead of calming. The line stops sweeping outward. The rescues end, and every loss becomes permanent. So, which universe do we live in for most of a century? Physics thought it knew. Every galaxy pulls on every other galaxy. Gravity drags against the expansion. All of it. Everywhere. All the time. The current had to be calming. The only question worth funding was how fast the slowdown was going, because the size of the slowdown would reveal the fate of everything. In the 1990s, two rival teams of astronomers set out to measure that slowdown, and both of them were certain of the outcome before they started. They built the instruments. They gathered the data. They ran the numbers. And the numbers that came back were so wrong, so completely upside down, that the first thing the discoverers did was go hunting for their own mistake. They never found one. To measure whether the universe is slowing down, you need to compare its expansion today with its expansion long ago. That sounds impossible until you see what Chapter 10 will make official. That looking far away is looking back in time. Light from distant galaxies left them billions of years ago and carries a record of how fast the universe was stretching back then. So the recipe is simple to state. Find objects so bright you can see them across billions of light years. So predictable you can trust them. Measure the stretching at each depth of the past. And read the universe's history like tree rings. Simple to state. Brutal to do. Because the recipe needs something, astronomy spent a century hunting. It needs a standard candle, an object whose true brightness is known. Everywhere. Every time. Hand me one of those and distance becomes child's play. because brightness fades with distance by an exact law. If you know the candle's true wattage, then how dim it looks tells you exactly how far away it burns. No guesswork, no ladders of assumptions. One glance, one number. The universe, it turns out, manufactures such a candle, and it does it with a bomb. Across the galaxies, there are countless pairs of stars locked in orbit around each other, and in some of those pairs, one partner has already died and collapsed into a white dwarf. A burned-out core the size of Earth with the mass of a star. So dense, a teaspoon of it outweighs a truck. A white dwarf is stable, but it has a weight limit. A critical mass built into the physics of matter itself. The same number everywhere in the cosmos. And a white dwarf with a living partner is a thief. It pulls streams of gas off its companion, feeding, growing heavier, creeping toward the limit for millions of years. When it gets there, it detonates. The entire star explodes in a runaway thermonuclear blast. And for a few weeks, that single explosion outshines its whole galaxy of 100 billion stars. Astronomers call it a Type 1, a supernova. And here is the gift. Because these bombs go off at the same critical mass, they detonate with nearly the same brightness. And the small differences between them give themselves away. No two of the blasts are perfectly identical twins. But the way each one brightens and fades over the weeks reveals its true wattage. So astronomers can read every explosion like a calibrated bulb. The same candle, lit again and again. All across the universe, all across time, catch one in a galaxy 5 billion light-years away. Measure how dim it appears, and you know the distance. Read the redshift of its light, and you know how much the universe has stretched since the explosion. Collect enough of them, near and far, and the history of the expansion falls out of the data. There was one catch. Nobody can schedule a supernova. In any given galaxy, a Type 1a goes off maybe once in a few centuries. The only way to harvest them is to photograph enormous fields of thousands of galaxies. Wait weeks. Photograph the same fields again, and hunt for any speck of light that changed. Then, the moment you find one, scramble the biggest telescopes on Earth to catch it before it fades. It is a stakeout of the entire sky. Run on deadline pressure. And in the early 1990s, 2 teams committed themselves to it. They could not have been more different, and they could not stand losing to each other. The first team grew out of Berkeley, California, led by a physicist named Saul Perlmutter. He was not even trained as an astronomer. He came from particle physics, the world of accelerators and statistics and automated searches, and he attacked the sky the way his field attacks everything, with software, wide cameras, and relentless scheduling. His group, the Supernova Cosmology Project, spent years being told by traditional astronomers that the plan could not work, that supernovae were too rare, too messy, too unreliable. They kept building anyway. The second team assembled in response, a group of hardened supernova specialists called the High-Z team, led by a young Montana-born astronomer named Brian Schmidt, working with a rising star of the field named Adam Rees. They knew the bombs better than anyone alive. Every quirk, every correction, every way a supernova can lie to you. They watched the Berkeley physicists charging into their territory and decided that if this measurement was going to be made, they would make it first and make it right. So through the middle 1990s, on mountaintops in Chile and Hawaii, and in the schedule of the Hubble Space Telescope, Two rival crews raced to do the same thing. Catch distant supernovae, measure the history of the expansion, and settle the great cosmic bookkeeping question. How hard is gravity breaking the universe? Understand clearly what both teams expected. The universe is full of mass, and mass drags on expansion. The only serious question on the table was the size of the slowdown, because the size of the slowdown would reveal the future. Enough breaking, and the expansion someday stalls and reverses, and the cosmos collapses back on itself. Too little, and it coasts outward forever, thinning and cooling. Fate, either way, was hiding in the deceleration. And the slowdown was so obviously coming that it was baked into the planning documents by name. The deceleration measurement. The supernovae began to arrive. Dozens of them. Faint sparks in galaxies billions of light years deep. Each one photographed, measured, corrected, logged, and by 1997, on both teams, independently, in mutual secrecy, the numbers started coming out wrong. The distant supernovae were too dim, not by much, a quarter of a magnitude or so, but too dim is too far. The candles were sitting farther away than any decelerating universe would allow them to be. Run the logic once, and it lands like a hammer. If the universe had spent billions of years slowing down, the stretching in the past was faster than today, and the supernovae should sit closer and look brighter. They look dimmer. The expansion in the past was slower than expected. The universe had sped up since then. The expansion of the universe is accelerating. On the high Z team, the calculation landed first on the desk of Adam Rees, who was crunching the data as a young postdoc in Berkeley. The numbers told him the universe was dominated by something with negative pressure, something pushing outward, and his honest reaction was that he had blundered. Somewhere in the chain, a sign error, a bad correction, something. He tore the analysis apart, hunting for his own mistake. The mistake refused to appear. When he showed the result to his teammates, the response across the collaboration ran somewhere between amazement and horror. And that is not my phrasing. That is how Brian Schmidt himself described it. These were people who had spent their careers learning every way a supernova can fool you. And their own data was telling them the most ridiculous thing a cosmologist could say out loud. They hunted for the exit. Maybe cosmic dust was dimming the distant candles, making them look too far. But dust reddens light in measurable ways, and the reddening was not there. Maybe supernovae in the ancient past were simply built dimmer. Different chemistry, different stars. The spectra came back matching the nearby ones. Twins across billions of years. One by one, every mundane explanation was dragged in, questioned, and released for lack of evidence. Meanwhile, across town, Perlmutter's team was living the same nightmare with their own larger stack of supernovae, their own software, their own methods, and arriving at the same upside-down answer. Neither team knew how deep the other's crisis ran. Both teams sat on the result, terrified of it, because in science the fastest way to end a career is to announce something enormous and be wrong. In January of 1998, at a meeting of the American Astronomical Society, the first hints went public. Through that winter and spring, in conference talks and papers, both teams laid their cards down within weeks of each other. Same answer. Independent data. Independent analysis. Bitter rivals. One conclusion. The expansion of the universe is speeding up. Something is stepping on the gas. That something needed a name. and a physicist named Michael Turner gave it one that stuck: dark energy. And here is the entire honest inventory of what humanity knows about it, delivered in one sentence, as promised. It makes up roughly 68% of everything that exists. It pushes the universe apart harder every year, and we do not know what it is. The rivals shared the Nobel Prize in Physics in 2011. Perlmutter taking one half, Schmidt and Rias splitting the other, and the certificates use the polite word acceleration. But tonight, with our messenger flying outbound through the dark, you are positioned to understand what those two teams actually found, better than any awards ceremony could say it. Chapter 7 left you standing at a fork between two possible universes. In the calming river, the break-even line sweeps outward forever. The rescues multiply, and patience eventually delivers almost every photon to almost every address. In that universe, distance is an inconvenience, and every letter arrives if you wait. The two teams measured which universe is ours. It is the other one. If the stretching strengthens with time, then the fast water spreads instead of calming. The rescues of Chapter 7 become rarer. Then stop. Regions drifting near the line get swept out instead of gathered in. Somewhere out there in the dark, addresses that could have been written to, worlds whose light would someday have arrived, are being moved, on by on, permanently, to the wrong side of the mail route, which is why those two teams did something bigger than win a prize. They took the map of everything and drew a second circle on it, closer than the first circle, harsher, and final, in a way. Nothing else in this story has been final. The first circle was a speed line, and light crosses speed lines. The second circle is a door. In the next chapter, we walk up to it, read what is written on it, and count how much of the universe is already on the other side. I will tell you now, the count is not close, and if this night has its hooks in you, this is the moment for the like button, and for subscribing if you are new to these long stories, because what comes next may be the strangest fact this channel has ever put on screen, and I want you here for all of it. Let us walk up to the second circle slowly, because unlike everything else tonight, this one deserves a little fear. The first circle was drawn by speed. It marked the distance where the stretching of space breaks even with light, and we watched it fail as an edge. Light slips across it. The line drifts. Swimmers get rescued. Mail from the far side lands on Earth every single night. Whatever that circle is, it is a current in the water. The second circle is drawn by something colder than speed. It is drawn by the entire future. Here is the question that defines it. And notice how different it is from any question we have asked so far. Forget what has already happened. Forget the ancient light already in flight, already in our telescopes. Ask instead about tonight. If a galaxy out there flashes a signal toward Earth right now, tonight, this very hour, is there any amount of waiting, any number of years, million, billions, trillions, an infinite allowance of time, after which that signal arrives? For nearby galaxies, the answer is obviously yes. The signal crosses. We receive it. Patience, pays. And in the old universe, the coasting universe everyone believed in before 1998, the answer stayed yes almost everywhere. Wait long enough and nearly every letter from nearly every address eventually finds its way home. Distance was never a refusal in that universe. It was only a delay. Then the two teams broke the speedometer, and the answer changed. In an accelerating universe, the fast water never calms. It spreads, The stretching between us and the distant galaxies grows stronger with time. And that reverse is the one mechanism that made the first circle leak. The rescue stop. A photon launched toward us tonight, from far enough away will fight the current forever and lose forever. Carried backward faster than it flies forward. Not for a long time. Not for an unreasonable time. But for all time. Somewhere out there is a distance beyond which a signal sent tonight can never reach this planet. No matter how long the universe runs, that distance has been calculated. Tonight it sits at about 16.5 billion light-years. Draw that sphere around us, and you have drawn the second circle. And its proper name is the cosmic event horizon. Every galaxy inside it can still, in principle, get a message to us someday. Every galaxy beyond it cannot. Light leaving those galaxies tonight will fly at the full speed limit of reality. Flawlessly, forever. And forever will not be enough. Their tonight is permanently unwatchable from here. Not delayed, erased from our future. Now turn the arrow around, because the horizon does not care which way the male is moving. The same stretching road that blocks their signals from reaching us blocks our signals from reaching them. Everything humanity transmits tonight, every radio broadcast, every laser pulse, every message we could ever compose, is bound inside the same 16.5 billion light-years. Beyond that line, no warning we send arrives, no greeting, no proof we ever existed. If there is a civilization out there in one of those galaxies pointing their telescopes our way, they can receive our old light for ages to come, the glow of a younger Milky Way, and they will never receive a single thing we do from this night forward. Both mailboxes are sealed, in both directions, at the same stroke. And here is the sentence this whole night has been climbing toward. Take it slowly. Some of the galaxies in tonight's sky are perfectly visible right now, sitting in our photographs, wearing catalog numbers, and tonight is already too late to ever reach them. It has been too late for billions of years. Visible and gone, both at once. You can point a telescope at them this evening and collect fresh photons, because their old light, the light of their youth, is still arriving and will keep arriving for a very long time. The picture works. The address is dead. Aim any reply at them, at the speed of light, starting this instant, and the reply wanders the stretching dark forever without arriving. We are in the strange position of watching, in high definition, places we can never answer, never visit, never touch, never affect in any way for the rest of time. The universe has already hung up, and the voice we hear is the recording. So count the damage, because this is where the night stops being about one photon and becomes about everything. Measure it by the volume of space we can see, and the reachable universe. The entire sphere inside the event horizon comes out to only a few % of the observable whole. Run that census across the sky, and the honest answer lands near this. Roughly 95% of everything we can see is already beyond the horizon. Roughly 19 out of every 20 galaxies in our photographs are permanently out of reach. Tonight, as a settled fact, and would remain out of reach, even if we launched a starship this evening that moved at the absolute speed of light and never stopped. Make sure that lands the way it deserves. This is not a claim about our technology being young. The ship in that sentence is a perfect ship. A physically impossible, idealized, flawless ship riding the hard ceiling of the universe. And it still arrives nowhere in roughly 95% of the visible cosmos. Almost everything you have ever seen in an astronomy photograph, almost every galaxy in every deep field. Every one of those glittering islands of 100 billion suns sits on the wrong side of a door that has already closed. The visible universe is, overwhelmingly, a museum of things we can look at and never hold. And what of our own messenger? Chapter 7 left its fate hanging on the river, and now the river has answered. The galaxy's currently inside 16.5 billion light-years. Our photon can still genuinely reach, and it will, sweeping past them one by one across the ages. But its actual target, the deep region at the edge of our maps, sits nearly 3 times beyond the door. The two teams settled our racer's case without ever knowing it existed. Our photon is flying toward an address that was moved out of the reachable universe before the laser ever fired. Put the two circles side by side, one final time, because the difference between them is the difference between an inconvenience and a verdict. The first circle is a speed line, and speed lines can be beaten by geometry, by shifting currents, by patience. The second circle is a causal boundary. On the far side of it, from tonight forward, cause and effect between us and them is finished. Permanently, in both directions, with no rescue written anywhere in the equations. The first circle lets the mail through. The second circle is where the universe stops delivering, which should leave you with one loud objection. And if it is already forming in your head, good, because it is exactly the right one. If nothing beyond 16.5 billion light-years can ever send us so much as a spark from this night on, then what have we been looking at all evening? The deepest photographs in existence reach out to the edge of the observable universe. 47 billion light-years, nearly 3 times past the horizon. We opened this night with that number. We have been staring across the uncrossable line the entire time. How can we possibly see almost 3 times farther than forever reaches? Because seeing was never touching. When you look out into that sky, you are not looking at the universe as it is. Every telescope on this planet is aimed at the past, and the farther it looks, the deeper into the dead past it reaches. The answer to the puzzle is waiting in the mail itself, in the ancient light already on its way. And it changes what every photograph in astronomy actually is. Step outside on a sunny afternoon and let the light hit your face. That warmth left the surface of the sun 8 minutes ago. You have never once seen the sun as it is. You see it as it was 8 minutes back, every day of your life. And if it winked out this instant, you would stand there in warm golden sunshine, comfortable and completely uninformed, for 8 more minutes. The news travels at the speed of light, and the speed of light, for all its glory, is a delivery schedule. That fact is harmless at 8 minutes. Watch what it becomes with distance. The nearest star beyond the sun shines on us from 4 years back. When you find it in the sky tonight, you are reading a 4-year-old letter. Most of the bright stars overhead are decades to centuries in the past, and a few are thousands of years gone, which means some of the stars in tonight's sky could have already died, and their obituaries are still in the mail, and no one on Earth can know until the darkness arrives on schedule. Now go to Andromeda. The neighbor, our photon, passed in Chapter 4. The farthest thing your naked eye can see. Its light spent 2.5 million years crossing to your backyard. When those photons launched, there was no such thing as a human being. Our ancestors in Africa were small creatures still learning what hands are for. And the light now entering your eye has been in flight for their entire transformation into you. You are not seeing Andromeda tonight. You are seeing the Andromeda of a world before people. And the real galaxy, whatever it looks like this evening, is a stranger no one on Earth has ever met. This is the trade the universe forces on every astronomer, and there is no negotiating it. Distance is delay. Looking farther is looking earlier. Every telescope is an instrument for receiving the past. And the great observatories of this planet are not windows on the cosmos so much as archives of it, sorting ancient mail by postmark. And the archive goes deep. In 2024, the James Webb Space Telescope confirmed the most distant galaxy ever identified by that point. A small bright system with the catalog name of JADES, GSZ-14. Its light traveled for about 13.5 billion years to reach the telescope's mirror. It shows us that galaxy as it was when the universe was younger than 300 million years old. An infant cosmos, barely 2% of its current age. Crowded and hot and still inventing itself. That photograph is a baby picture from nearly the beginning of time. Now ask the question this night has trained you to ask. Where is that galaxy at this moment? 13.5 billion years have passed since the portrait was taken. The road between us has been stretching the entire time, and stretching harder in the recent ages. Run the numbers and the galaxy in that image, whatever it has become, if it still exists in any recognizable form, sits tonight more than 33 billion light-years away. Check that address against the second circle. The event horizon stands at 16.5 billion light-years. This galaxy's present-day self is twice as deep into the forbidden zone as the zone is wide. The infant we photographed grew up, moved away, and moved to a place from which no letter can ever again be sent to Earth, and to which nothing from Earth can ever be delivered. We have its picture. The universe has permanently disconnected the line, and once you see one photograph that way, you cannot unsee any of them. This is what the deep sky actually is. Every image in every archive is a portrait of a sender who has moved on. And for the distant ones, a sender whose current address is on the wrong side of the horizon. The light arrives fresh tonight, focused and measured and real, and it is the only part of them that will ever arrive again. The galaxies themselves, tonight's versions, are beyond every reply. In the plainest words I can find, the deep sky is a wall of ghosts. Faithful, glowing, punctual ghosts, delivering the same old news forever to anyone with a mirror to catch it, which turns the observable universe inside out. Those 47 billion light-years we opened the night with are not a distance you could travel even in principle, because the thing they measure is not spread across space tonight. It is spread across time. The edge of the observable universe is not the farthest place we can see. It is the earliest time we can see, out at the very rim of our maps. We are not looking at the far side of the cosmos. We are looking at the beginning of it. So push the archive to its limit. That is the obvious next move. And astronomers made it decades ago. Build a bigger mirror. Take a longer exposure. Reach past the infant galaxies toward the beginning itself. Further back. Further back. You would expect the images to simply fade with depth. Older and fainter and older and fainter, until the past runs out of light and the archive trails off into black. That is what you would expect. It is what nobody found. Push deep enough and you do not fade into darkness. You hit light. A solid, unbroken wall of it, standing behind everything, glowing from every direction at once. North, south, up, down. Everywhere you point. The same wall, at the same depth surrounding this planet like the inside of an eggshell. It is the oldest light in existence, and it marks the absolute end of seeing, the place beyond which no telescope that will ever be built can look. Humanity found that wall by accident. Two radio engineers in New Jersey were trying to get rid of a hum in their antenna, and they could not. And the reason they could not is that the hum was the wall, and the wall is the universe itself. And before they figured that out, they spent an afternoon chasing a pair of pigeons. To understand the wall at the bottom of the sky, you have to run the movie of the universe backward. And the movie does something simple and violent. It compresses. Run time in reverse and the galaxies crowd together. The space between them shrinking. The temperature climbing, because squeezing anything heats it. Keep rewinding and the galaxies dissolve into gas. The gas thickens and glows. And somewhere before the first 400,000 years, the entire universe becomes something with a surface temperature hotter than a star. Every cubic inch of existence, everywhere, glowing orange, then yellow, then white hot. There is no dark sky in that era, no night, no black anywhere, because there is no empty space to be black. The whole cosmos is a single continuous furnace. And a furnace like that has a property that matters more to tonight's story than its heat. It is opaque. In that era, matter was a plasma. Atoms torn apart into loose electrons and bare nuclei. And free electrons are where light goes to get lost. A photon in that universe could not fly in a straight line for more than a moment before slamming into an electron and ricocheting off in some new direction. Then again, a pinball in a machine with no exits. Light existed in blinding quantities, and light could not travel. The infant universe was a wall of fog from end to end, luminous and sealed, and if you could somehow place an eye inside it, that eye would see what a miner sees inside solid rock, glow with no view. Then, 380,000 years after the beginning, the fog broke, and it broke everywhere at once. The universe, still expanding, cooled through a threshold. The temperature where electrons can finally settle into orbit around nuclei and hold roughly the surface temperature of a star, about 3,000 degrees. In a stretch of time brief by cosmic standards, the free electrons across all of existence were captured into the first stable atoms, and the pinball machine lost its bumpers. Light that had been trapped since the beginning of time suddenly found nothing in its way. Picture the scale of that single event, because nothing else in history compares to it. In every direction, across every inch of an entire universe, all at the same cosmic moment. The fog lifted and the light poured out. Every photon in existence, released simultaneously, flying off in whatever direction its last collision happened to point it. The universe went transparent in one stroke, and its entire supply of imprisoned light was set loose into the newly opened sky at once. An eruption of brightness with no center and no edge, happening everywhere. Some of that light flew in directions that, 13.8 billion years later, end at a small blue planet. It has been in flight ever since. It has never touched anything, and it is still arriving, tonight, at this planet, from every direction at once. That is the wall. When our deepest instruments look out past the last galaxies, what they run into is this. The released light of the moment the fog broke, coming at us from all sides, the glowing inner surface of our own past, wrapped around the sky like the inside of an eggshell. We cannot see past it for the most honest reason in physics. Beyond it, light could not fly. There are no straight photons from the fog years for any telescope to catch. The wall is not where the universe ends. The wall is where seeing ends. There is one more thing the flight did to that light. And it is the detail that hid the wall from humanity for decades. 13.8 billion years is a long ride on a stretching road, and the road stretches everything on it, including the light itself. Every wave of that ancient white-hot glow has been pulled longer and longer across the ages, stretched by a factor of about 1100, from brilliant visible light down past infrared, all the way into microwaves. The same territory as a kitchen appliance and an old television antenna. The most violent flash of light in all of history arrives at Earth tonight as the faintest whisper of microwave static, 3 degrees above absolute zero, humming in from everywhere, which is exactly why the people who found it had no idea what they had found. In 1964, at a place called Holmdel, New Jersey, 2 young radio astronomers named Arno Penzias and Robert Wilson were preparing a giant horn-shaped antenna, a 20-foot funnel of metal originally built for satellite communication, for pure science work. Before measuring anything faint, you map your noise. Every radio instrument hums with interference, and the job is to account for every source of it until the leftover is zero. Penzias and Wilson were meticulous men, and they accounted for everything. The city of New York, glowing with radio chatter just over the horizon. The atmosphere, the heat of the instrument itself. They cooled their receiver with liquid helium to nearly the coldest temperature possible, and when all of it was subtracted, the leftover refused to be zero. A faint, steady hiss remained, and it made no sense at all. It did not come from any direction in particular, which ruled out New York, the sun, the galaxy, any single source in the sky. It came from every direction equally. It did not change with the time of day, which ruled out Earth. It did not change with the season, which ruled out nearly everything else. Day after day, month after month, the same quiet hum from the entire sky at once. They went hunting for the flaw in their own machine. And this is the part of the story that deserves to be true, and is. A pair of pigeons had nested inside the great horn, and the birds had coated the antenna's throat with what the 2 scientists, writing formally, described as a white dielectric material. Here were 2 of the best radio astronomers alive, wondering if the strange signal from the whole universe was pigeon droppings. They evicted the birds, scrubbed the horn clean, and climbed back to the receiver. The hiss had not moved. Close to a year they spent on it, checking, cleaning, doubting, and the hum outlasted every explanation on their list. Meanwhile, 30 miles away at Princeton University, a physicist named Robert Dick had spent that same year leading a small team toward a prediction. If the universe began hot and dense, they reasoned, the light of that era should still be out there, stretched by the expansion into a faint microwave glow filling the entire sky. And they were building an antenna to hunt for it. Then Dick's office phone rang. It was Penzias, describing a stubborn, uniform, unexplained microwave hiss coming from everywhere. Dick listened, answered his questions. One hung up, and turned to his team with a sentence that has entered the folklore of physics. Boys, we have been scooped. The 2 groups published together in 1965, one paper describing the hum, the other explaining it, and the interpretation has survived 6 decades of increasingly merciless testing. The hiss in the horn was the flash of the breaking fog, the released light of the young universe, arriving 13 billion years late and stretched 1100-fold, straight into a New Jersey antenna that was pointed at the sky for entirely different reasons. Penzias and Wilson had discovered the oldest light in existence while trying to make it go away. It won them the Nobel Prize, and it settled the deepest argument in cosmology. Because a steady, eternal universe makes no such glow, and a universe born hot cannot avoid making it. The Big Bang stopped being a hypothesis the day the pigeons were found innocent. Astronomers call that wall the cosmic microwave background. And in the decades since, satellites have mapped it across the whole sky in exquisite detail, revealing the faint mottling in its glow, the slightly warmer and cooler patches that would later grow into the galaxies, and the great foam of filaments our Photon flew through in Chapter 4. It is the baby picture of everything, taken at 380,000 years old, surrounding us forever in every direction. The end of the archive, the last page, and now you are standing exactly where I have wanted you all night, because you hold every piece of the opening puzzle. And one small question springs the trap. The wall of light is the oldest, most distant thing we see, the very rim of the observable universe, the source of the 47 billion light-year number from Chapter 1. So ask it, when that ancient light began its journey toward us, 380,000 years after the beginning. How far away was the matter that released it? How long was the road? On the day the trip started, the answer has been measured. On the day that light launched, the glowing matter that released it stood about 42 million light-years from the matter that would one day become the Earth. 42 million, not billion, million. The light crossed a starting gap of 42 million light-years. The trip took 13.8 billion years, and tonight the sender stands 47 billion light-years away. Those three numbers should not be able to live in the same universe. In the next chapter, we watch them become each other, and the impossible arithmetic of Chapter 1 finally comes home. Here is a race with numbers that should embarrass the racer. A beam of light, the fastest thing in existence, sets out to cross a gap of 42 million light-years at the full speed limit of the universe. That trip should take 42 million years. It took 13.8 billion. The runner needed 300 times longer than the course should demand. And when it finally crossed the finish line, the starting line was 47 billion light-years behind it. 1,100 times farther than the whole original course. Nothing in that paragraph is a mistake. Every number in it is measured. Tonight, we make them make sense. And I will keep the promise from Chapter 1. The whole proof runs on a flashlight. Go back to the beginning of the trip. 380,000 years after the Big Bang. The fog breaks, and a patch of glowing gas releases its light. 42 million light-years away sits another patch of gas, the one that will someday cool and gather and become the Milky Way. The sun, and you. Our beam launches across the gap, flying at the perfect speed of light through its own local space, aimed at the matter that becomes Earth, and the gap explodes. The young universe was expanding at a rate the modern universe cannot imagine. The whole loaf rising furiously in its first ages, and the road between those two patches of gas was being stretched violently while the beam flew. Run the honest bookkeeping on the first stretch of the journey. The beam flies forward 1 light-year, and behind and ahead of it. The road grows by more than that. After 1 million years of perfect flight, the distance to the destination is larger. And after 10 million years, larger still. Our beam is the swimmer from Chapter 7, stroking flawlessly toward a shore that the current is dragging away faster than any swimmer moves. Measured against its goal, the fastest thing in existence is traveling backward. By the time the arithmetic turns even slightly merciful, The gap of 42 million light-years has been stretched to hundreds of millions, and the beam has covered enormous ground while losing it. Any sensible bettor watching that opening would tear up the ticket. The race is unwinnable. The gap grows faster than light. Case closed. The bettor forgets one thing. The current is not constant, and this racer cannot die. Remember what the early universe was made of. Matter. Everywhere. Dense and heavy. And matter pulls. Every galaxy tugging on every other. All of it dragging against the expansion. And in those early ages, the drag was winning. The furious stretching of the young universe was slowing down. Century after century. Era after era. The river was fast. But the river was tiring, and the beam of light does not tire, does not age, does not slow, and does not care how long the fight takes. It holds its speed while the current fades. And somewhere in the deep past, the balance quietly tips. The stretching of the road directly ahead of the beam drops below the speed of light. The gap to the destination stops growing and starts to shrink. This is the turn of the entire journey. So, see it plainly. The beam did not speed up. It cannot speed up. The road gave up first. From that turning point on, every year of flight brings the destination genuinely closer. Slowly at first, against a still swollen gap, now hundreds of times larger than the original 42 million. Then faster as the expansion keeps calming through the matter-dominated ages. The swimmer that spent its youth being dragged out to sea spends the next several billion years grinding back toward shore, mile by stolen mile, across a road that fought it the whole way out, and now, slowly, lets it come home. 13.8 billion years after launch, the beam arrives. It falls out of the New Jersey sky into a metal horn, stretched 1,100-fold by the road it survived, and gets mistaken for pigeon droppings. That is why 13.8. The trip took 300 times longer than the starting gap because for ages the racer was moving backward relative to the finish line. And the racer won anyway, because it entered the one contest where never slowing down eventually beats any current that weakens. Patience is not a virtue at the speed of light. It is the whole strategy. Now the second number, while the beam fought its way toward us. What happened to the place it came from? The sender got carried the other way. That patch of glowing gas, 42 million light-years off at the start, has been riding the stretching road away from us for the entire 13.8 billion years, and for the recent several billion of those years, riding it faster, because the two teams from Chapter 8 discovered the current has begun strengthening again. Add up the whole ride and the sender's address tonight sits about 47 billion light-years away. The 42 million became 47 billion. Same road. Same stretching. Opposite direction. The messenger crossed the river while the river carried its home out to sea. And with that, the two numbers from the top of the night clicked together at last. 13.8 billion years is the age of the universe. The flight time of the oldest light. 47 billion light-years is where the senders of that light have been carried by tonight. The first number measures the trip. The second measures where the starting line ended up. They were never in conflict, because they were never measuring the same thing. The typo from Chapter 1 dissolves, not because anything was wrong, but because the road between the two numbers refused to hold still. I promised you a flashlight, and here it is. Stand outside tonight and switch one on. Aim it at the sky. The beam leaving your hand is physically identical to the ancient beam we just followed. Same speed, same physics, same rules. And the road it enters is the same stretching road. Everything that happened to the light of the breaking fog will happen. In mirror image, to the light leaving your fist, racing outward while the space behind it stretches. Its remaining distances swelling, its home shrinking, to a memory being carried backward at speeds that will someday exceed its own. Your flashlight beam is the cosmic background radiation of some far future sky. And the proof of the impossible number from Chapter 1 is sitting in your kitchen drawer. So the opening mystery is solved, and solved with time to spare. But before we move on, look once more at the two swimmers of tonight, because setting them side by side explains something Chapter 9 could only declare. The ancient beam won its impossible race for one reason only. It crossed the river in the era when the current was dying. Matter ruled the young universe. Gravity dragged the brakes. And a racer that never quits could simply outlast the water. Our Photon, the one on the mountaintop, launched into the opposite era. It is crossing the river in the age when the current is coming back to life, strengthening year over year, with no end written anywhere in the data. Same river, same rules. Opposite tide. That is the whole difference between the Photon that made history and the Photon that is making an exile of itself right now. Tonight, somewhere out past the filaments, one entered the water as the river was giving up. Ours entered as the river was waking up. And a river that is waking up does more than doom one messenger. It redraws the map of everything, every night, while nobody watches. The three circles we have spent this night discovering are not parked at their addresses. They are moving, all of them, and the direction they are moving decides who in this universe can ever touch whom again. It is time to put the whole map on the table and let it run. Every map you have ever trusted made you one silent promise. The territory holds still. The coastline you sail toward tonight is the coastline that will be there in the morning. Cities stay put. Rivers keep their beds. And the distance between any 2 points is a fact you can write down once and use forever. Every mile of human navigation rests on that promise. And it is honored so reliably on Earth that no sailor in history ever thought to question it. Tonight we own a map of everything. And the promise is broken on every line of it. One honest sentence before we run it. Everything from here to the end of the night assumes the current keeps strengthening the way our best measurements say it is. And that is the strongest assumption science can offer right now. So we will take it and go. If the universe has a surprise hiding in its engine, our descendants will get a different ending. The data we own points one way. So build the living map. Put Earth at the center, because that is where our telescopes stand, and draw the three circles at their true scales. The first ring, 14.5 billion light-years. The break-even line, thin and leaky. A current in the water. The second ring, 16.5 billion. The door, the event horizon. The edge of everything we can ever touch. The third ring, 47 billion. The archive wall, the limit of everything we can see. Somewhere between the first ring and the second. Small beyond any drawing. Our Photon is still out there, running perfectly, exactly as it has all night. Now release the clock, and watch what a century does. The third ring moves outward. Watch it go. The edge of the observable universe swells by a little more than 1 light-year every year. And that motion is easy to misread as generosity. So read it carefully. It is old light arriving, 1 year deeper into the fog era's aftermath. A slightly earlier, slightly more stretched whisper of the same ancient morning. The map of the past grows 1 ring of ghosts wider. That is the entire gift. Now watch the second ring. The door. the only ring that governs the living future. Its distance in miles, tonight, is holding nearly steady. But distance in miles was never what the door measures. The door is a sorting line for galaxies, and the galaxies are not holding still. The stretching road carries them outward through the rings. Every one of them. Always. And so the true measure of the door is its guest list. The count of galaxies still inside, still reachable, still on our side of forever. That list only shrinks. Run the map forward and you can watch it happen. A galaxy sits just inside the second ring, a few million light years shy of the line, close enough that a signal launched tonight would, across billions of patient years, still arrive there. The road stretches, the galaxy drifts through the doorway, and the moment it crosses, a switch flips somewhere in the bookkeeping of the universe that no instrument anywhere records. Tonight a message could have reached it. Tomorrow night, nothing ever will. No alarm sounds. The galaxy itself feels nothing, notices nothing, changes in no way at all. Its stars burn on. Its worlds keep turning. Only its relationship to us has died. Silently, permanently, in both directions at once, while both of us were doing something else. That is the living map, the archive ring sweeping outward, collecting ever older light from ever deader addresses. The door holding its ground in miles, while its guest list bleeds, and the traffic between them running one way only, outbound, forever. Galaxy after galaxy, filing quietly out of the reachable universe and into the museum. Here is the sentence the whole map has been building toward. So take it slowly. The number of things we can see goes up. The number of things we can reach goes down. Both at once, both forever, and both by the same machinery. The same stretching road doing both jobs with the same motion. Our sky grows richer every year. Our future grows poorer every year. The map fills while the territory empties. And that trade rewrites the title of tonight's story. The distance between us and the edge of the universe was never a number. Numbers hold still. This is a number with a motor bolted to it. And after everything you have now seen, you know the reading on the dial matters less than the direction it turns. 47 billion tonight. More tomorrow. The question that actually decides everything, the question hiding under the title this whole time, is which way is it moving? And the answer, for every purpose that touches the future, is away. Before we leave the map running, look at it one last time and notice something strange about how we built it. 3 rings, and every one of them drawn around the same point. Us, the break-even line. Ours, the door. Ours, the archive wall. Ours, the entire apparatus of tonight. Every boundary, every horizon, every forever, has been measured outward from one small planet, as if the universe kept a special set of borders just for Earth. It does not, and seeing why is the strangest turn left in the night. Take one step off this map, stand somewhere else, anywhere else, and every ring you just watched me draw dissolves and redraws itself around your new address, at full scale, as if Earth had never existed. The edge of the universe is not where the universe ends. It is where you end, and the next chapter proves it. Let us run an experiment that no one can ever run, and let us run it carefully, because everything in it, except the travel, is real. Pick a galaxy from tonight's photographs. Any of them will work. So take one from the museum. A spiral sitting 20 billion light-years out. One ring past the door. In the roughly 95%. We have its picture. We can never touch it. Now put your mind inside it. On some rocky world orbiting one of its several 100 billion suns, standing in some observatory under their night sky, and ask the only question tonight knows how to ask. What do they see? They see a universe with themselves at the center of it. Their sky is wrapped in the same wall of ancient light, the same stretched glow of the same breaking fog, arriving from every direction at once, at the same depth in every direction. They're astronomers. If they have run the same century of measurements we have drawn the same 3 rings, a break-even line at 14.5 billion light-years, a door at 16.5, an archive wall at 47, the same numbers, the same physics, the same forever, drawn around them. Their observable universe is a sphere of the same size as ours, centered on their world. And here is where the experiment turns strange. Overlay the 2 spheres, theirs and ours. 2 circles of radius 47 billion light-years, whose centers sit 20 billion light-years apart. The circles overlap through the middle like 2 searchlights crossing in fog. The overlap contains both of us, and a vast shared library of galaxies we have both photographed, both catalogued, both named in our different tongues. For everything in the overlap, we own the same ghosts. Their archives and ours hold portraits of the same objects, taken from different seats in the same theater, but their sphere reaches 20 billion light-years past ours on their far side. And that crescent of sky, that enormous sliver of everything beyond our archive wall, is full of galaxies with light in their telescopes tonight. Galaxies with catalog numbers in their archives. Galaxies their astronomers photograph on ordinary working evenings. And not one of those galaxies has ever appeared in any instrument on Earth. No photon from that crescent has ever landed here. Not one. In 13.8 billion years. Their sky overflows with things that, from our seat, have never existed in any measurable sense at all, and never will. And on our far side, the mirror image. Our archives reach 20 billion light-years beyond their wall. Into a crescent of the universe their world has never received a single spark from. The deep field photographs we have spent this night walking through, some of the oldest galaxies humanity has ever laid eyes on, are from their observatory. Nothing, no picture, no name, no evidence. 2 civilizations, each holding an archive of wonders. Each archive containing marvels the other cannot verify exist. So ask it plainly, where is the edge of the universe? There is no answer. There is only, where is the edge of yours? Their edge and our edge are both real, both measured, both exactly 47 billion light-years in radius. And they are not the same sphere. Move the observer, and the whole apparatus moves with them. Silently, instantly, completely. Every galaxy in existence sits at the center of its own observable universe, wearing its own 3 rings, wrapped in its own wall of first light. 2 trillion galaxies in our sphere alone, and every one of them is the middle of everything. From where it stands, the universe does not have an edge the way a country has a border. It has an edge the way a lighthouse has a beam. 1 per lighthouse, going wherever the lighthouse goes. You have met this before. It is the horizon from the boat in Chapter 2, standing 3 miles out on the Pacific, real and measurable and centered on you. And the sailor 100 miles away owns a different circle of ocean, equally real, centered on them, Nobody asks where the horizon of the Pacific is. There is no such thing. There are only horizons of sailors. Tonight we learn the sky works the same way. There are no edges of the universe. There are only edges of observers, and ours is just the one with our telescopes inside it. Now, that discovery drags a large question into the room, and I am going to answer it the way the evidence answers it, which is briefly, and then I am going to put it down. Because this channel deals in measurements, and the measurements on this question run out fast. If every observer owns a private sphere, and every sphere is packed edge to edge with galaxies, then what is the universe entire? How far does the full territory run? Out past every sphere, beyond all the beams of all the lighthouses. Cosmologists have one real handle on the answer: geometry. If space curves, the way Earth's surface curves, then a large enough universe closes on itself and has a finite size you could in principle state. The curvature of space is measurable, written faintly in the mottling of the wall of first light, and it has now been measured about as well as this era of instruments can measure it. The verdict: no curvature detected. Flat. To the precision of everything we own. And flat cuts two ways. A flat universe can run on without end, or it can be so enormous that its curvature merely hides below our instruments. A sphere so vast, our whole observable universe sits on it like a postage stamp on Earth. Reading the ground as level, the honest bounds say the entire universe is at minimum hundreds of times the volume of what we see, and the true answer may have no bound at all. Nobody knows. Nobody may ever know. And any voice claiming certainty past that line has left the measurements behind. What the evidence does license is this, and after 14 chapters you have earned it. Beyond our archive wall, in every direction, there is almost certainly more galaxies, more walls of ancient light around other centers, more spheres of other skies. The word beyond does not point at an ending. It points at territory that has simply never reported in, which lands us somewhere almost comfortable. And you may enjoy the comfort for exactly one paragraph. No edge to fall off, no wall closing us in. Every observer a center, abundance in every direction, a cosmos that may never run out. It sounds, for the first time all night, almost generous. Now remember what the map does when the clock runs. Every one of those private spheres is governed by the same machinery ours is. Every observer's door is bleeding its guest list. Every sky in existence is trading its reachable galaxies for museum pieces. Everywhere, all at once, and no local fact, no clever species, no fortunate address is exempt from the trade. The generosity is real, and it is all in the seeing. The losing is just as real, and it is all in the reaching, and it is running tonight, at full speed, in every sphere at once. So far, the door has been an abstraction, a line in the bookkeeping, a switch that flips with no alarm. It is time to stand at the door and count the traffic, because something is passing through it as you watch this, at a rate someone has actually calculated. And once you hear the number, the sky over your house will never look quite the same again. Somebody did the math. That is where this chapter starts. Because the claim I am about to make is strange enough that you deserve to know it was not made carelessly. Astrophysicists have taken the measured expansion, the measured acceleration, and the measured census of the sky, and they have computed the traffic through the door, the rate at which the contents of the universe are leaving our reachable future, permanently, in real time, tonight. The answer is usually quoted in stars. Depending on how you count, the published estimates land near this. Every second, roughly 20,000 stars slip across the event horizon and out of our future. Every second. 20,000 stars. By the time this sentence finishes, another 100,000 suns, many of them presumably with their own planets, their own moons, their own weather, have crossed the line beyond which no signal from Earth will ever arrive, and no new signal of theirs will ever reach us. Over the length of this video, the count runs to something like 100 million stars, while you slept last night. 500 million, added up across a year, and the departures amount to the stellar population of entire galaxies. A few galaxies worth of suns, every single year, filing out of the reachable universe forever. Since the day you were born, the universe has moved the contents of dozens of great galaxies from the column marked someday to the column marked never, and every one of those departures is final in the fullest sense that physics allows the word. Watch the machinery of one departure up close. Because the details are stranger than the headline, take a single galaxy sitting tonight just inside the door, a few million light-years shy of 16.5 billion. Nothing about it is unusual. Stars are being born there tonight, and stars are dying. And if there are worlds with oceans, the tides are coming in on schedule. The galaxy is not racing anywhere. It sits as still in its own patch of space as we sit in ours. But the road between us is stretching. The stretching is strengthening. And the bookkeeping is merciless. Night after night the galaxy's distance ticks upward. And at some particular moment, on some particular date that could in principle be computed, the total stretching between us crosses the fatal threshold, and the galaxy passes through the door. Here is what that moment looks like from inside that galaxy. Nothing. No jolt. No shadow. No change in their sky or ours. No creature on any world that could ever detect the crossing. Because locally there is nothing to detect. The door is not a place. It is a relationship. A fact about the road between two addresses. And when it dies the way a friendship dies across a widening distance. Without a sound, without a moment you could point to, noticed only later. And only if somebody checks. And now the detail that turns this chapter over. The one that sounds impossible until you see it. We will never watch them leave. Your instinct says that a galaxy exiting the reachable universe should exit the visible universe too. It should wink out, fade to black, leave a hole in the photographs. That is not what happens. The old light keeps coming. Every photon the galaxy launched before the crossing is still in flight, still inbound. A pipeline of ancient mail millions of years long. And that pipeline keeps delivering long after the sender has passed the door. Our telescopes will keep receiving that galaxy, photographing it, measuring it. For billions of years after tonight, the picture survives the departure. But watch what happens to the picture, because this is where the accelerating universe signs its work. And the signature is one you have seen before in a very different place. As the road to that galaxy stretches harder, the light crawling along, it gets stretched harder too. Redder and redder, fainter and fainter. And the movie slows down. The galaxy's clock, as seen from Earth, runs slower and slower, its stars aging in ever more sluggish motion. Its light arriving from moments spaced further and further apart in its history. The image does not vanish. The image freezes. It dims toward invisibility while slowing toward stillness. An ember cooling in the frame. forever approaching a final frozen frame. It never quite reaches. If that behavior sounds familiar, it should. It is exactly what an object does when it falls into a black hole. Watched from outside, a falling astronaut never visibly crosses the event horizon of a black hole. Their image slows, reddens, dims, and freezes at the edge, a permanent ghost fading on the boundary, while the astronaut themselves, in their own experience, crossed over long ago and continued on. Physicists have known for decades that the two situations are mathematical cousins. A cosmic event horizon treats the whole distant universe the way a black hole treats what falls in. And that means the sentence this chapter has been building toward is not poetry. It is the literal optics of our sky. We are watching the universe fall away from us, and everything that falls leaves its picture behind on the way down. So this is what the emptying actually looks like. And it is nothing like the darkening room your instinct pictured. The sky never goes dark on any night anyone alive will see. The sky fossilizes. Galaxy be galaxy. The living cinema of the deep sky is being converted into a gallery of freeze frames. Images still glowing, still collectible, still beautiful, whose subjects have left the building. The museum from Chapter 9 is not just large. It is growing. 20,000 suns every second. And the exhibits never come off the walls. They just stop moving. And the roughly 95% becomes 96. And the 96 will become 97. And the machinery grinds in exactly one direction, with nothing in the measured universe positioned to slow it down. Every year, the part of the cosmos that can still be touched gets smaller. Every year, the part that can only be remembered gets larger. The trade runs at full speed over your house every single night. Silent, invisible, and, as far as the data can see, permanent. Now follow the machine forward. Because a machine like this has a destination. Run it for 1,000,000 years. And the guest list thins by whole clusters. Run it for 1,000,000,000. And the far galaxies of tonight's photographs are frozen embers scattered across a slowing sky. Keep running it. Past the lifetime of the sun. Past ages that make tonight's numbers look quaint. All the way out to 100 billion years. And the machine finishes its work. The last outside galaxy crosses the door. The last ember cools past every instrument. The sky over every world in our neighborhood arrives at a state it will then hold essentially forever. And someone will be standing under that sky. There will be stars burning there. And there can be worlds circling them. And there is nothing in physics that forbids astronomers on those worlds. Clever ones, careful ones, building great telescopes and doing everything right. The next chapter belongs to them. We are going to stand under the finished sky, look through their instruments, and follow their perfect, flawless, honest science to its conclusion. Their conclusion will be wrong. Every measurement will be right. And the conclusion will be wrong. And the reason is the most unsettling thing this story has left to say. If this night has earned it from you, this is the moment for the like button. And for subscribing if these long stories are new to you, because we are 2 chapters from the end of the deepest road this channel has ever walked. And the strangest turn is the next one, 100 billion years from tonight. Let us be honest about the neighborhood first, and then meet the people. The sun is long gone, burned through its fuel about 95 billion years earlier. But that was never going to be the end of starlight. The galaxy is full of red dwarf stars. Small, cool, absurdly frugal suns that sip their fuel so slowly they can burn for 1 trillion years or more. and under their steady glow, worlds can still be warm, chemistry can still run, and there is no law anywhere in physics that says minds cannot exist there. So put minds there, curious ones, patient ones, the kind that grind lenses and keep records. Astronomers, one correction to the scenery before we look through their telescope, and it comes with the only good news this chapter holds. Their galaxy is probably not the Milky Way. Our galaxy and Andromeda, the neighbor our Photon passed in chapter 4, are falling toward each other right now, and they are likely to collide and merge a few billion years from tonight. Though the latest orbital measurements no longer make that future a complete certainty, merged or simply bound together, the outcome that matters is the same. Our local cluster of galaxies, the Milky Way, Andromeda, and their few dozen small companions, is lashed together by its own gravity firmly enough to defy the expansion forever. The door can never take what gravity already holds. So the reachable universe has a flaw, a final permanent, untakeable estate. And this island of stars is it? Everything the far future keeps. It keeps here. Now stand on one of their worlds, under their night sky, and look up. The sky is magnificent. 1 trillion stars, the combined populations of the merged neighborhood, wheeling overhead in a single vast glittering city of light. Their astronomers can map it, measure it, chart its orbits and its history, and they will do beautiful science on it, because it is a beautiful thing, and beyond it, nothing. Look past the last stars of their galaxy, in any direction, with any instrument, at any exposure, for any length of time, and the answer is a black, so complete it has no features to study. Every outside galaxy crossed the door ages ago. 20,000 suns a second. Every second, for 100 billion years, until the job was done. Every frozen ember faded below every conceivable detection. The wall of first light, the ancient glow that filled our sky and gave away the universe's secret, has been stretched by all that expansion into wavelengths so long and so faint that no instrument they could ever build will find it. The fossil sky itself has crumbled. Their universe, as far as any measurement can testify, is one galaxy of stars, an island of 1 trillion suns, floating alone in a featureless, permanent dark. Somewhere out in that dark, for whatever it is worth, our Photon will still be running. Here is where the chapter turns. Because the point was never that the far future is dark. The point is what the dark does to the truth. Watch their astronomers work, and give them everything. Physics as good as ours. Mathematics as good as ours. Telescopes better than ours. And 10,000 years of patient, careful, honest observation. Every experiment they run will run clean. Every measurement they make will be correct. They will measure the positions of their stars, year after year, and find no expansion anywhere, because inside a gravitationally bound galaxy there is none to find. They will search the sky for other galaxies and find none, because none remain within reach of any instrument. They will hunt for a glow of ancient light and find none, because it has been stretched beyond the end of every dial. And then they will do what good scientists do. They will follow their flawless evidence to its honest conclusion. The universe is one galaxy, floating in a static, eternal void. It is not expanding. It has no edge, no horizon, no history of fire. It has simply always been here, a city of stars in an empty room, and it always will be. Every step of that reasoning is correct. Every input is accurate. The conclusion is wrong from end to end. And there is nothing they can ever do about it, because the evidence against it has physically left their sky. That is what makes this frightening, and it has nothing to do with intelligence. You could hand their greatest minds our textbooks, our photographs of 2 trillion galaxies, our maps of the ancient light, and they would have no way to check a single page. Every claim points at things outside their door forever. Our truth would land in their world as an unfalsifiable myth, a strange scripture about a bigger cosmos. And their most rigorous thinkers would be right, by every standard of evidence they own, to shelve it next to their other legends. Two physicists, Lawrence Krauss and Robert Scherer, worked through this scenario in detail and published it, and their conclusion deserves to be carried out of this chapter. The far future universe hides its own history. The expansion erases the evidence of the expansion. The observers of that era will do everything right and arrive at the wrong universe. And they will never be able to know they are wrong. And the picture they will land on, the single galaxy adrift in a static, eternal void. You have seen it before. It is precisely the universe humanity itself believed in through most of its history. And as recently as the early 20th century, before Hubble proved the spirals were galaxies, before Humasson's plates caught the sky in flight, before the horn antenna in New Jersey heard the fog break, the astronomers of 100 billion years from now will hold, with perfect evidence, the exact cosmology we held in 1915 out of simple ignorance. The difference is that we could grow out of ours. The proof was still in the sky, waiting for a big enough mirror. Their sky will have finished deleting the proof, which drags the flashlight around and points it at us. And this is the paragraph the whole chapter exists for. We are not the audience of this story. We are inside it. The machinery emptying their sky is the machinery emptying ours. Tonight, 20,000 stars a second. And the evidence that taught us the truth is a shipment, passing through. And the shipment does not repeat. The wall of first light fades as it stretches. The distant galaxies redden and freeze. Every mind that ever understands where the universe came from will understand it because of when that mind happened to exist. Inside the window, while the mail was still arriving, we sit in that window now. It is closing at a measured rate. It will not reopen. A window like that asks one question on the way out, and I will hand it to you in a single line and then leave it alone, because no one can ever answer it. If the sky deletes its evidence over time, what did it delete before we arrived? So the far future is settled. The window is real, and we know exactly what waiting costs, which leaves precisely one direction left to look. And it is the direction every viewer of this channel has been waiting for me to face. Forward, our sky is still full. Our evidence still arrives nightly. And our species is young, clever, and famously bad at accepting the word never. The horizon is a wall built by physics. This channel has spent whole nights watching human beings take walls apart. So let us ask it, seriously and honestly, with everything on the table, telescopes, machines, new kinds of messengers, new physics, all of it. Is there any way through? Humanity has a long and proud history of being told never and hearing not yet. We were never going to fly. And then we flew. We were never going to leave this planet. And then boot prints appeared on the moon. So the question deserves a fair hearing, with no thumb on the scale. Tonight we bring every tool our species owns, or could ever own, and we test the wall. There are 4 doors to try. Let us try all 4. Door number 1 is the obvious one. Build a bigger telescope. It sounds promising, because bigger mirrors have been beating limits for 4 centuries. Galileo's little tube found moons around Jupiter. The 100-inch on Mount Wilson found the galaxies. The James Webb found infants at the dawn of time. Every generation of glass has pushed the map outward, so surely the next generation pushes it past the wall. Here is why it cannot. A telescope is a bucket for light. A bigger telescope is a bigger bucket. And a bigger bucket catches more rain, fainter drizzle, older storms. What no bucket of any size can do is catch rain that never fell. The limit at the edge of the observable universe was never about the faintness of the light arriving. It is about light that has not arrived, because the road is too long and the time since the beginning is too short. Beyond the wall of first light, there are no straight flying photons to collect. At any faintness, in any exposure, with any mirror, you cannot photograph mail that was never sent to your address. The bucket makers will keep sharpening the map inside the wall, and the wall will not move for them by 1 inch. Door number 2 is subtler, and it is the only door in this chapter that actually opens. Change messengers. Everything tonight has traveled by light, and light has one weakness we found in chapter 11. For its first 380,000 years, the universe was fog, and light from before the fog broke is simply gone as information. But light is not the only messenger physics owns. When the fabric of space itself is shaken violently enough, it ripples, and the ripples fly outward at the speed of light, passing through matter as if it were not there. Gravitational waves. In 2015, humanity heard them for the first time. 2 black holes colliding over 1 billion light-years away, wobbling every ruler on Earth by less than the width of an atom's core. And we caught it. And here is what makes that miracle matter tonight. The fog that stopped light does not stop gravitational waves. Ripples born in the very first instant of the universe, before the first second was finished, would have flown straight through the entire fog era untouched. And they would still be passing through this room tonight, unimaginably faint, waiting for an instrument sensitive enough. The same goes for the universe's most antisocial particle, the neutrino, which shrugs off matter so completely that trillions of them are passing through your body as you hear this. Relic neutrinos from the first moments are predicted to fill the sky. A fossil older than the fossil. So door number 2 opens. And let us be precise about where it leads, because this is the difference between a real hope and a false one. New messengers can carry us deeper into the past. They can take us behind the wall of first light, into the fog itself, maybe to the opening instant. What they cannot do is take us farther out in the map of tonight. Gravitational waves and neutrinos obey the same speed limit. Light obeys. They ride the same stretching road. Every horizon this night has drawn. The break-even line. The door. The causal limits of the reachable universe. Applies to them exactly as it applies to light. Wave for wave. Particle for particle. The new messengers read older pages of the same book. They do not add pages. The archive deepens. The territory does not grow by one galaxy. Door number 3 is the one science fiction has been leaning on for a century. Cheat. Go faster than light. Warp drives. Wormholes. Folded space. And I will not wave these away with a smirk, because the honest situation is stranger than a simple no. In 1994, a physicist named Miguel Alcubierre took the warp drive seriously enough to hunt for it inside Einstein's own equations. And he found something, a configuration of space-time, a bubble that contracts the road ahead of a ship and stretches the road behind it, surfing the vessel along on a wave of moving space. The mathematics is real and published. Wormholes have a similar status. Genuine solutions of the equations. Tunnels connecting distant points of the map. And every one of these constructions runs into the same toll booth. To bend space that way, the equations demand a substance with negative energy. Matter that weighs less than nothing. Gravity that pushes instead of pulls. In quantities that in some versions rival the mass of stars. In the entire history of experiment, no such substance has ever been observed in usable form, and several theorems suggest the universe actively forbids gathering it. And behind the toll booth stands a worse guard. Any machine that beats light also beats time. Faster than light travel. Run through the same relativity that makes it thinkable. Permits messages into the past. Effects before causes. Answers before questions. And there is no agreed way to keep a universe consistent once that door is open. So the honest verdict on door 3 is this. It is locked by the rulebook itself. And to open it, our descendants would have to discover that the physics we have tested for a century is wrong in its foundations. Nothing we have ever measured says that page exists. The door stays shut until the universe itself says otherwise. And it has been saying otherwise. In every experiment. For 100 years. Which leaves door number 4. The quietest one. And the one this channel loves best. Do nothing clever at all. Just wait. Patience is the oldest cheat code in astronomy. And it used to be the best one in the universe. In the cosmos everyone believed in before 1998. The coasting universe, with gravity easing the brakes. Waiting bought you everything. Every year, the horizon reached farther. Every century more mail arrived. And a civilization that simply endured would watch the map grow richer forever. New galaxies rising into view, like ships coming over a curve. Every address eventually writable. Every letter eventually deliverable. In that universe, time was the great ally. The tide that lifted every boat. Deep patience was a strategy for touching everything. The two teams with the supernovae did not just break the speedometer. They broke the strategy. In an accelerating universe, waiting works backward. Every year of patience. The door swallows another 20,000 suns a second. Every century. The reachable universe is poorer than the century before. Sit still for 1 billion years and you do not gain the sky. You lose most of it. The tide is going out. And it will go out for as long as the data can see. And the boats it lowers do not come back. Time. The ally that made every other impossible journey merely a matter of endurance, has switched sides. On this road, and on this road alone. Patience is the enemy's weapon. So fold up the plans. Because we have now tried everything there is. Bigger eyes see older ghosts. New messengers read earlier chapters. Faster than light waits on a revolution no evidence has ever hinted at. And waiting itself now works for the other side. 4 doors. And behind all 4. The same answer. Wearing 4 different faces. The horizon holds. There is nothing left to try. And only one thing left to do. Somewhere out there. Deep past the filaments. Our messenger is still running. We fired it at the edge of everything at the start of this night. And we owe it one last visit. It is time to bring this home. The Photon does not know how the night went. It is out there right now. Past the last landmarks with names. Running through the dark between the filaments at the full speed limit of reality. It has not slowed by 1 step since the laser fired on the mountaintop. And it never will. No clock ticks for it. No distance tires it. In the ages ahead it will thread galaxies we have photographed and never touched. Sweep past worlds that will never learn it came from somewhere. And cross the door. Outbound. Into the roughly 95%. At which point every possible thread between it and this planet is cut forever. It will still be running when the sun dies. It will still be running when the island galaxy of Chapter 16 floats alone under its empty sky. It will run at the fastest speed that has ever existed, for as long as there is a universe to run through, and it will never arrive, because somewhere along tonight's road, arrival stopped being a place and became a moment, and the moment passed before the laser ever fired. Back in Chapter 3, I asked you to mark the launch, and I told you it was the last moment. The trip still looked winnable. Now you know the whole truth folded into that sentence. The trip never looked winnable to the universe, only to us. The target sat at the edge of our maps, and the edge of our maps had already been carried 3 times deeper than forever reaches. We did not enter a race that night. We mailed a letter to an address that had been erased. And the letter cannot be recalled, and the letter will outlive everything we know. So let us stand where we started, and read the title of this night one last time. With everything we now own, the terrifying distance between us and the edge of the universe, tonight that distance is about 47 billion light years, and the number turns out to be the least of it. The edge is not a wall, and there may be no wall anywhere. Only more universe past every map. The distance is not a length of road. It is a length of time. 13.8 billion years of it. The deepest past that has managed to reach us. The number is not still. It grows every night. And the growth is the whole story. Because the same stretching that swells the map is carrying the territory away. We can see almost 3 times farther than we can ever reach. Roughly 19 of every 20 galaxies in our sky are already beyond every possible touch. The pictures keep arriving from senders who have left forever. 20,000 suns slipping out every second. And the evidence that let us understand any of this is itself in the mail. Passing through. Fading as it goes. That is the real distance. It was never measured in light years. It is measured in the difference between what we can know and what we can hold. And it is the widest gap that has ever been found. And yet the strangest fact of the whole night is standing right at the end of it. Quietly. Like it has been waiting for us. Everything we just learned crossed that distance to get here. Somewhere tonight, on this planet, a telescope is tilted up at the dark, into its mirror. This very second, ancient light is falling, photons that launched before the Earth existed, that fought the stretching road for 13 billion years, that outlasted the galaxies that made them, are ending their journeys tonight in a camera on a mountaintop, carrying the only news of places nothing from here will ever visit. The universe cannot be reached. It can only be heard from, and it is heard from, every clear night, free of charge, in the oldest light there is. That light does not say here is the final wall. It has never said that. What it says is simpler, and after tonight you can read it. This is as far as the universe has had time to tell us about itself. Tomorrow night it will tell us a little more. 1 year deeper, 1 whisper older, to whoever is still looking up while the window is open. If tonight changed the way that sky looks to you, a like helps this channel more than you know, and a subscribe means you will be here for the next long night. This one is over. Good night.